Hey guys, welcome back. This is Mr. Marone here. Here on topic 3 of your summer packet. So this coincides with the angle and segment addition postulates piece of your summer packet. Okay, we're going to look at both the angle addition and the segment addition postulates and an example of each. And they're identical to each other. The biggest difference is that one refers to segments, and the other refers to angles, as you could guess by the names. Geometric terms are fairly literal in their naming. So we see here with the segment addition postulate that if I have three collinear points, A, B, and C, and B is between A and C, then the piece of the segment that is created by points A and B plus the piece of the segment that's created by points B and C equals the whole thing. Basically take anything, take a piece of spaghetti, take a piece of paper, and cut it into two pieces. If you put those two pieces back together, they're going to create the whole thing all over again. Same idea here with segment addition postulate. And when you see this is generally going to introduce a little bit of algebra into it. So for instance, they gave us this example where they told us segment EG had a measure of 59 units. And they gave us measures in algebraic expressions for EF and for FG. So in order for us to use the segment addition postulate, it's this piece EF plus this piece FG equaling the whole thing EG. So if I write that down, I can come over here and write that 8x minus 14 plus, that's EG or EF, plus FG, which is 4x plus 1, equals that full size measure of 59. Okay? I can then combine my like terms, so I end up with 12x minus 13 equals 59. And then you can just solve out just like you would any other algebraic problem. So we've got 72 equals 12x, so x equals 6 in this case. Now, when you come from algebra, that's the feeling of accomplishment, the feeling of being done with a problem. But if you notice, up in the question, they asked for the actual measures of EF and of FG. So we now have to take one more step and say that EF was equal to 8x minus 14. We have to plug back in. So 8 times 6 minus 14, sorry. So we have 48 minus 14, which ends up giving us 34 for segment EF. And once again, we're going to label it with that line over the top. Okay. And we have to do the same thing for FG. Segment FG equaled, oops, sorry guys. FG equals 4 times 6 plus 1. So I've got 24 plus 1. So FG equals 25. Okay, and then we would be done. And you could verify your answers. If you add up 34 and 25, you do get 59. Okay. Now, the angle addition postulate is identical, only now we're dealing with angles. Okay, so if point B is inside angle AOC instead of being collinear, then the shaded yellow segment AOB plus the shaded blue segment BOC together create the outside angle AOC. We're just putting the angles together. It's the same process. So if we took a look at an example of that, we've got the figure on the right, and they tell us that angle RQT, that should be a Q, but we lost our little mark there, RQT is 155 degrees. And once again, note that they want us to find the actual angle measures. Okay, so that's key to note down. So we're going to start out by combining our like terms. So we've got 4x minus 20 plus 3x plus 14 equals that 155 degrees they mentioned up above. And combining like terms, we have 7x minus 6 equals 155. And when we solve this all the way out, you should have that x equals 23 here. Okay. Now, when we plug back in for our angle RQS, we have 4 times 23 minus 20. So angle RQS will end up with a final measure of 72 degrees. And if we plug in for SQT, angle SQT, and that equals 3 times 23 plus 14. So we end up with angle SQT equaling 83 degrees. Okay? And if you want to verify it, 3 plus 2 is 5, and 8 plus 7 is 15, which gets us back to our 155 degree measure. So take a look at these, keep these in mind as you work through your practice problems on this. Note that angle addition postulate and segment addition postulate are the same rule with two different geometric figures. And stay tuned for our next summer topic video.